with example 30. In the town of illness, the number of cases of a particular disease, D, can be modeled by the equation D equals D0 e to the power kt, where t is the time in years. Using available medication, the number of cases is being reduced by 20% each year. There are 10,000 people with the disease today. Question number 1 asks, how many people will have the disease after 1 year? Now, we can't use the formula yet because there's too many unknowns. So what we know? Well, we know that in 1 year, there will be 100%, take away 20%, there will be 80% of the population because 20 of them will be healed. Okay, let's just zoom in again. 80% will be there. So what is 80% of 10,000? So 80% of 10,000 equals 80 over 100 times 10,000, and that equals 8,000 people. Right, so therefore there will be 8,000 people after 1 year. Question number B. Question B. Find the value of k correct to 3 decimal places. Now the problem is, E is a constant value. We know how many people we start off with, but that leaves us with k and t, which is unknown. Because I have 2 unknown values, I need 2 equations. So let's quickly go and see what we have here. If I have the time, so when time is 0, and the number that we have is 10,000, let's see what will this equation be. So what we'll have is, we'll have 10,000, according to that value there, we'll have 10,000 equals D0 e to the power k, we don't know what k is, but t is 0. K times 0 is 0, anything to the power 0 is 1, so e to the power 0 is 1, so do equals 10,000. Okay, I'm going to move here. I'm now going to do what is when time is after 1 year. I know that D then equals 8,000. Okay, so let's substitute that into the formula. So we know that D equals D0 e to the power kt. D is 8,000, oh sorry, that's not 80,000, that's 8,000. 8,000 equals, we started off with 10,000, e to the power k, and the time, we said this is after 1 year, so that is 1. So that gives us, and I'm just going to swap 2 sides, I'm going to have e to the power, k times 1 is k, and that equals, I'm going to divide by 10,000. That gives us 8,000 divided by 10,000. Now what I'm going to do is I'm going to take ln both sides to get rid of e. Alright, and if I take ln on both sides, that k will move to the front. So that k will go to the front, and that will equal the ln of the left hand side, 8,000 over 10,000. Ln e is 1, therefore k equals, I use my calculator, on, clear, there's my ln. I'm going to say the ln of 8,000 divide by 10,000, close bracket, enter, is negative 0.223. So negative 223. What did they ask? They say K correct to 3 decimal places, 1, 2, 3 decimal places. That will give us negative 0.223. So that is K. Let's look at what they want in C. In C they say write the equation substituting for K and D0. So I know that D equals, what is D0? D0 is what we found here, it's 10,000. E to the power K, we know what K is, it's minus 0.223, and T depends on what time it is, and that's where that T comes from. So that's my equation at any time. If I now want to know in D, find how long it would take for the number of people with the disease to be halved. Okay, so to be halved, it means that D needs to be 5,000. D needs to be 5,000. So if D is 5,000, I will get 5,000, and I'll just substitute that 5,000 back into this. 5,000 equals 10,000 e to the power minus 0.223 t. I'm going to divide by 10,000, and I'm going to swap sides. So it's going to be 5,000 divided by 10,000. Okay, and I'm going to bring this over, and I'm going to take e to the power negative 0.223 t. I'm going to take ln on both sides, or I'm going to write it in exponential form, which gives us minus 0.223 t equals the ln of 5,000 divided by 10,000 is a half. So t equals the ln of a half, the ln of 0.5 divided by negative 0.223. Okay, so I'm just going to store this on my calculator. That last minus 2.22, I'm going to store that by saying store answer as my x value, right? And I'm going to say clear the ln of 0.5, ln of 0.5, close bracket, divide by, I'm going to say x, because that's the one that I stored. And time is 3.106. This will be years. Okay, 3.106 years. They say, the question is, find out how long it will take the number of people with disease to be halved. Give you answer correct to the nearest year. It will take a little bit more than 3 years to the nearest year. So they say correct to the nearest year. So it will take about 3 years to do that. So round it off, 3 years. I'm going to move this up so I can just have a little bit extra space to do the last question. And the last question I will do in dark green. How long will it take for the number of people in the disease, with the disease to be reduced to 100? Okay, so we want to reduce it to 100. So I'm just going to use my formula, and I'm going to start at D over here. I'm going to say D. Sorry, this is question number E. So I'm going to say for D equals 10,000 e to the power minus 0.223 t. Therefore, D is 100 equals 10,000 e to the power minus 0.223 t. Okay, I'm going to divide by 100 both sides. Sorry, by 10,000 both sides, and I'm going to get e to the power minus 0.223t equals 100 divided by 10,000. That will cancel, so we'll have 1 over 100. I take ln both sides, and I'm going to move this to the front. So it's going to be negative 0.223t equals the ln of whatever is remaining over here, which is 1 over 100. Therefore, t equals ln of 1 over 100 divided by negative 0.223. On my calculator, clear. I'm going to say the ln of 1 divided by 100, close bracket, divided by negative, clear, I'm going to say ln of 1 divided by 100, close bracket, divide by, and I'm going to use my x because that's stored that value, and the answer is 20.64 years. How long will it take the number of people to reduce to 100? Now, in 20.64 years, there will be 100. So we will say, give your answer correct to the nearest year. It will take 21 years for them to be reduced to 100. So the answer is 21 years.